Hello, good morning, good evening, good afternoon, pre-algebra party people. As was promised yesterday, we are going to start translating word problems and situations into algebra. So this is the first time, but not the last time, we are actually going to start using algebra as part of the problem-solving process. So let's get some examples of what we're talking about today. Um, I'm going to start this with a little bit of a caveat. When we're translating equations, these equations that we are going to see, I would suspect that most people will be able to solve without algebra in any way, shape, or form. But what we are learning to do, what the skill that we are practicing right now is a three-step process, okay? A three-step process that is going to be used throughout this year so that we can practice using algebra for what it was meant to do, making uh, an abstract language of a mathematical relationship. So to do this, we have to, first of all, let's consider the words that meant to add, subtract, multiply, and divide that we learned the other day. Okay, you have a whole list of them that are in your notes. We'd also have to recall some words that mean equals in math, particularly the big one that's all right in here. The word is, and all of the other possible ways that you could represent is or was or turned out to be or will be. Okay, so we have a comprehensive list of that from yesterday's notes. I would suggest, if you're still not familiar with some of those words, to review that. Okay, so using I'm going to skip this practice since we've already gone over the homework today, hopefully, if all has gone well. Okay? To solve a word problem using equations, you must first identify what we are trying to find, the unknown. We are going to assign it a variable. Assign it a variable. For example, t is equal to the number of turtles. Okay? Next, you must translate the word problem into an equation. All right? So if it said 2 times the number of turtles was 12, you would say, okay, 2 times, in this case, t, is 12. And then finally, the third part would be to solve said equation using inverse operations. And hopefully you would know by this point in the unit that you would have to undo the multiplier 2 by dividing by 2 on both sides. And the value of t should be 6. So that three-part process is the way that we are going to do things. Those are going to be our norms. And like I said, I want you guys to adopt a growth mindset when doing this, adopt a beginner's mindset, meaning that even if you can solve the word problem without any algebra at all, let's practice this process so that we can start applying it on some more difficult scenarios. Okay, so let's get in a guided example. This one's easy, right? Level easy. Douglas is 12 years old. He is 4 years older than his sister Brianna. How old is Brianna? So the first step, define the variable. What is the unknown here? Well, it's Brianna's age. So we'll have to say B is equal to Brianna's age. That'd be the first thing that you would write. Then let's go back. We're going to have to translate this to algebra. We have to translate this to an equation. And let's pick out the math words. We have 12 years old is 4 years older than, that's like more than, okay, his sister Brianna. All right? So reading from left to right, we would have the number 12. We'd have is, which means equals. We'd have the number 4. We'd have plus. And then we'd have his sister Brianna. So it would translate into 12 equals 4 plus b. And then last, hopefully you can solve this and to be able to figure out that Brianna's age is, yes, 8 years old like everyone knew to start from, right? So spoiler alert, if you did not know Brianna's age was 8, now you know. You have used algebra to solve something, right? Not that you needed algebra for that. Let's get another example. Let's up the ante to a two-step one, okay? Oh yeah, and this note says, let's retranslate it to make sure that it makes sense, okay? Brianna is 8 years old. Let's plug that back into the scenario. And yes, that of course makes sense. Next one says Wade's 5 pairs of shoes is one less than half of his sister's collection. How many pairs of shoes does his sister have? Okay, well, it's what's unknown here. Well, the first one is thing that is unknown is we don't know how many pairs of shoes his sister has. So let's define a variable, right? So S is equal to his sister's shoes. I chose S. You could choose any really letter that you would like. And then it's going to say 5 pairs is one less than half of his sister's collection. Interesting. Okay. So, like the ones that we had on our homework, 5 is, there's our equal sign. 1 is the number 1. Less than, careful there, that's an order switcher. So I'm going to have to switch the order of the 1 and whatever it is being subtracted by. And then half of his sister's collection. 5 is 1 less than half of his sister's collection. Okay, this is interesting. All right, so it should be 5 equals something being cut in half and then subtracted by 1. 5 is equal to S divided by 2, subtract 1. There's another way that this could look. If you wrote 5 is equal to 1/2 of means times 1/2 S minus 1. Those mathematically do the same thing. And we did discuss that when we went over the homework and some examples yesterday, right? So let's go ahead and solve it. You would have to add the 1 to both sides, then multiply by 2 on both sides, and hopefully we'd be on the same track that S is equal to 12. And let's plug that back in to see if that makes any sense, okay? S equals 12. What does S stand for? Sister's shoes. That means his sister has 12 pairs of shoes, okay? And does that make sense? Wade's 5 is 1 less than half. All right, so absolutely, that does make sense by my mathematical reasoning. Let's get a little tougher even still. Ooh, wordy. An airline allows every passenger to carry a maximum of 36 kilograms of baggage. Kilos, including checked baggage. Okay? Carl's 2 checked bags are of equal weight, and his backpack, I'm assuming that's his carry-on, weighs 4 kilograms. Carl's baggage weighed exactly, when it totaled out the exact limit, exactly 36. What is the weight of each of Carl's checked bags? Okay, interesting here. So, in this case, what is the unknown? We have to define the unknown. Well, the unknown would be the weight of each of Carl's checked bags. So let's say B is equal to the weight of each bag. It's not of both bags, it is of each bag. Okay? And then if you have 1B is the weight of a checked bag, how many bags does he have? He actually has 2 of them. So you can actually write B plus another B plus 4 equals 36, or you can simplify that by combining the like terms. B plus B is actually 2B. And that makes sense. He has 2 bags. He has 2 bags plus 4 is equal to 36. We've been modeling stuff like this for a reason, right? So if you had to model this on your desk, you would have, I know we didn't have B blocks to model, but we would have an X plus another X plus 4 extra results in 36 on the other side. Then you'd have to solve by subtracting the 4 and then dividing the 2. 2B is equal to 32 in this case, and B is equal to 16. And what does that mean? Well, that means each of his bags weighed 16 kilos, kg as abbreviated. All right, so there might be ones where you have to have some distribution, where you might have to have some like terms even, like that one insinuated. All right, let's try one on your own here. Pause the video and see if we come up with the same exact solution here. All right, so in the 2000 presidential election, Indiana had 12 electoral votes. That was Bush versus Gore. Very tight presidential election. That was 20 votes fewer than the number of electoral votes in Texas, much bigger state, Texas. How many electoral votes did Texas have? So let's define the variable. You should have defined T is equal to votes for Texas, which I'll abbreviate TX. Translate to an equation. 12 was, so 12 equals 20 votes fewer than is an order switcher. So I'll go T minus 20. Now let's solve the equation and retranslate it to make sure that it makes sense. So these are the 3 things that I'm looking for. Did you define a variable? Did you have the equation 12 equals t minus 20? And then did you finally solve by adding 20 to both sides to find that 32 is equal to t? And then retranslating this. You don't have to necessarily write something, but it does always help to read, to say, okay, Texas had 32 votes. And that makes perfect sense because 32 votes is 20 more than 12, or 12 is 20 fewer than 32. Pause this one, pause the video now, and then check to make sure that we got the same thing. All right, welcome back. Hopefully you define the variable. In this case, it says in the driest part of an outback ranch, cows need 40 acres each for grazing. Cows take up a lot of land when they eat all of the plants and vegetation, I guess. How many cows can graze on 720 acres? So C is equal to the number of cows that you're looking for. 40 each. So when I referenced the other day that each was a sneaky word that meant multiplication. So 40 times the number of cows is equal to 700 and the resulting 720 acres. And hopefully when you divide by 40, you can find that the number of cows is 18. So 18 cows can graze on that particular acreage. What about this one? Mandy is trying to buy a new Kindle. The sales clerk says if she pays $80 now, Hershey is a typo there. She will only have to pay $32 each month. That's her monthly payment, and the total cost will be that's the future of is 400. How many months will she have to make payments? All right, so go ahead and see if you can write the algebra for this, and let's see if we write the same solution set. All right, welcome back. So hopefully you defined something like this. M is equal to the number of months. If you said X or N or something like that, that's fine. You didn't have to pick out M like I did. Translated to an equation, $80 now, that goes down. She will also have to pay $32 every month. And each, there's that each again. There's that each word again. And then the total cost will be $400. So it's 80 plus 32M equals 400. 80 plus 32M is equal to 400. And of course, that could look a little different. That could look like 32M plus 80 equals 400, or have the 400 on the other side. Though all of those variations are fine based on your properties. And then hopefully when you solve that, you'd found that M, the number of months, is 10. The number of months is 10. Here's what I want to be careful of. Here's what I want you guys to be careful of. And this is what I'm going to be hard on people about. To practice solving this, I know that this is not necessarily needing of algebra to solve this certain problem, right? But some people come into this lesson and they want to define what M is, and then the translation looks something like this. M is equal to 400, take away the $80 payment, and then divide by 32. Okay? That's not what I want to see. And the reason being that I don't want to see that is because you have done all of the solving. You have done all of the solving in the translating step. And I want to get away from that. I want you to actually set up the equation based on the way that it was written in the problem and then solve it afterwards. It takes a little practice to do that because working backwards is a great problem-solving plan that you've used in elementary school. It's a great problem-solving plan that you've used in 5th or 6th grade. But I'm trying to get you to think about how can you write algebra as a problem-solving plan. So to do that, we have to start with some easier problems, okay? Let's do this last one together, and I know there's more examples, but this is where I'll cut the video. It says Aaron Leary, who I have no idea who that is, bought a bunch of old bikes at an auction for $350. He fixed them, and he sold them for $50 each. There's that each word again, hint, hint, wink, wink. And then he made a profit of $6,200. So this is sort of a business setup here. And the question is, how many bikes did he sell? So I won't have you pause the video. Let's do this one together. Hopefully you have something like this. B is equal to the missing number of bikes that were bought Actually, not bought, not necessarily. We actually don't know that. It's asking for how many bikes did he sell. Bikes sold is what I should define the variable as. Okay? Translating to an equation. Now, this is interesting. There's some good business words in here. Profit. Profit is found by taking the amount of income that you've taken in and subtracting your expenses. Profit is equal to the income, take away the expenses. And one of these numbers in here is Aaron Leary's expenses, or his investment, if you will, in this bike business. Okay? So translating to an equation, you would find that the $6,200 profit that he has made was equal to the $50 each for each bike that he has sold. $50 B times B, $50 for each B, each bike sold. But we're going to have to subtract the 350, or actually, let's do this a different way, plus negative 350. And hopefully you recognize that the $350 is his expense. That was his investment into this business deal. Okay. Sorry, I keep getting jammed up. It's late in the day. And then we'd have to solve this here. We'd have to solve this by adding 350 to both sides. Adding 350 to both sides, and that gives me 6,550 is equal to 50B. And then I'll divide by 50 on both sides. Let's see if we can mental math this here. So a 0 over a 0 when dividing, those will cancel out. And 5 goes into 65 13 times. And then it goes into that other 5 one time. So I think I can mental math this here. And the answer would be 131 is equal to B. Let's see if that makes sense. So he's saying that the number of bikes that he sold was 131. So if we plug that back in, we've got $50 times 131 would be this gross profit is, or this gross sales, 6,550 gross income. And then let's subtract the $350 investment that he had, and that does work out to his profit of $6,200. So that does work out. Okay? Like I said, that's where I'll cut the video for right now. I know there's other practice examples. If you have questions about that, please check in with me. See you guys.